A spurious correlation is something we have probably seen a lot of in the last 20 months of the pandemic, and can be very frustrating when one is used publicly to support a point of view or bias. The concept of spurious correlation was first introduced by Carl Pearson in 1897. Pearson describes how a significant value for a coefficient of correlation can be obtained when the two variables in reality are absolutely uncorrelated. In other words, two completely unrelated variables appear to have a near-perfect relationship, which may lead to causal inferences being drawn, despite no actual relationship between the two. As you can see from the graph in this post, a near-perfect relationship is observed when comparing the total revenue generated by arcades and the number of computer science doctorates given out in the United States of America. These are both independent variables, but by looking at the graph, there is a 98.5% correlation between the two, which could lead us to assume that they are related, but in fact they are completely unrelated. It's a common error to think that correlation and causation go together. In fact, this thinking isn't completely unreasonable, because when one thing causes another, the two tend to be associated and therefore correlated. For example, effort and results, inspection and quality, or investment and return. However, as the saying goes, correlation isn't causation. You can have a correlation, but that doesn't mean that it's causal. Think of it this way: the correlation is just a number that reveals whether large values of one variable tend to go with large or small values of the other variable. A correlation doesn't really explain why the two independent variables are associated. Going back to using the mentioned example of investment and return, the correlation provides no sense of whether the investment is producing a return, or in fact vice versa, is the return producing the investment. The correlation just indicates that the numbers seem to go together in some way, shape or form. It's possible though that for a correlation without causation, that there is some hidden or unobserved third factor. In this scenario, it can appear that one of the variables seems to cause the other, when in fact each is being caused by a missing third variable. In a spurious correlation, it may be that the high correlation is actually due to some third factor. There is no way that the spurious correlation indicates that something meaningful about how the world actually works. It then becomes a question of what is the possible causal connection between these two things, or these two variables. When researching, we need to be careful that we aren't making so many different comparisons that we actually end up finding similarities that exist by chance, as opposed to what is actually occurring in any real world relationship. The example in this graphic demonstrates a positive relationship between the two independent variables, but as I've said before, they are completely unrelated. However, the same thing can happen when comparing decreasing quantities. If we compare an increasing quantity with a decreasing quantity, we will get a correlation as well, but it will actually be a negative correlation. One example is the media reports about the proposed health benefits of red wine. It's been seen before that one week it's reported that a single daily glass of wine increases heart disease risk, and then the next week the same glass of wine actually decreases this risk. This becomes confusion for the consumer and probably the scientists as well, which are probably both the same person anyway, and I do apologise to all my wine-loving professors over the years. From a media perspective though, as long as the research finds a relationship, it suddenly becomes a news story. However, when the follow-up study finds that the relationship was actually spurious, does this make good reading for consumers? Probably not, and is lesser reported. In general, the correlation coefficient refers to the linear correlation coefficient between two variables, which is used to describe the degree of linear correlation between the two variables. However, a spurious correlation demonstrates a seemingly causal relationship between two correlating variables. While the correlation is statistically existent, like the 98.5% correlation between arcade revenue and computer science doctorates in this graphic, they're not based on any cause or effect relationship. For more fascinating spurious correlation examples, such as the relationship between per capita cheese consumption and the number of people who died getting tangled in their bed sheets, it's worth checking out Tyler Vigen's web